For this first question, we're given this function, y equals x squared minus 4x plus 3. So we're given this quadratic. First thing off the list is to find the derivative. So I'm going to do that just by calling it y dash. And I'm going to use the power rule on each term. So I've got 2x minus 4. Then I need to complete this table and determine the nature of the stationary points in Sketch. So in this case, it actually wants me to evaluate these points. So I'll do that this time, but on the next question, I'm just going to look at the signs because that's what's important for stationary points. So at x equals 1, and we're always looking at this function here, making sure that y dash, we want to make sure looking at the right function. So I've got 2x minus 4, so 2 of these, so that's 2 minus 4 will be minus 2. Then I've got 2 here, so 2 times 2 is 4, minus 4 will be 0. And I've got 3 times 2 is 6, minus 4 would be 2. So I'm going to draw little pictures underneath because they help me a little bit more. Negative gradient, flat spot, positive gradient. Now we can really see what's happening here. It tells us to determine the nature of the stationary point. Stationary where the derivative is 0 and the nature is, it's going to be a minimum. So this is so we say here that at x equals 2, we have a minimum turning point. Bottoms out here. Now we need to sketch this function, so putting in as much detail as we can on these particular sketches. So what I might do is I might also factorize this to be minus 3 minus 1. So then the minus times the minus can be positive, but I get minus 4x. This will tell me the roots. So that's really important. So I can see that there's a root at 3 and a root at 1. That's what crosses the x-axis here. When x is 0, I can see that the y-intercept is going to be 3. And I've got a minimum turning point where x is 2. And when x is 2, I'm going to have 4 minus 8 is minus 4 plus 3 is minus 1. So I'm going to be here at minus 1. And that's my minimum value. Putting all that together, it means I need to pass through here, down through this point, bottoms out, goes on, and this goes up here to 3. Something like that. There we have. That's our sketch for question 1. We're going to the next question. It's exactly the same. It wants us to find the derivative first. So term by term, we're going to have 4 minus 2x. Wants us to complete this table, making sure that we're matching and we're finding the derivative here. So at the point where x equals 1, I've got 4 minus 2. So that's 2. 4 minus 4 is 0. And 4 minus 6 is minus 2. So what I've got is positive, flat spot, negative. This really helps me determine the nature. We have a stationary point where the derivative is 0. And more than that, we actually have a turning point because it changes gradient there. So we would say that it is a maximum turning point at x equals 2. Now we need to sketch that, putting in as much detail as we can. So I know that when x equals 2, I've got 12 plus 8 is 20, minus 4 is 16. So at the point here, I've got 2, 16 is going to be my maximum turning point. When x is 0, these terms disappear. I end up with a y-intercept of 12. So it's going to cross out here. It's going to bottom out. I'm negative on this side, like that. Positive on this side. Like that. I still need to find the x-intercepts here. And to find the roots, what we're going to do is factorise this quadratic, and I've done that here. I'll see I've got a root here at minus 2 and a root here at 6. So there we are.